So in this video, we're going to talk about gas laws, okay? Now, the first thing we should know is that the units, okay? And so 1 millimeter mercury is equal to 1 torr, and 1 ATM is also equal to 760 millimeters mercury, or 760 torrs, okay? So the units are very important. So let's talk about the relationships. Now, there are three laws that we need to familiarize ourselves with, okay? And so if I take a look at this, well, the first one is Boyles Law. And what Boyle's law says is that as the pressure increases, the volume decreases. Okay. And the temperature and number of moles are constant. Only if the temperature and the number of moles are constant. So in Excel, or maybe you're doing your lab, the volume should be on the y-axis, the pressure should be on the x-axis. And what you should get is this some sort of quadratic looking like function, which means that they're just inversely related. So the volume is equal to approximately, or the pressure is equal to approximately 1 over the volume. Okay, so that's what Boyle's law says. Now the formula that we should know in order to solve any Boyle's law problem is this: P1 V1 is equal to P2 V2. Okay. Now in the next video, I'm going to talk about how we do not actually have to memorize the formulas. But for now, we should know that the volume, we should know the formula for Boyle's law is given by P1 times V1 is equal to P2 times V2. Okay. And so with that being said, let's look at a problem. So what if we have this problem here? It says if a gas has an initial volume of 2.75 liters and a pressure of 1.02 atm, and the volume is increased to 3.25 liters, what is the new pressure? So essentially, if I'm looking right here, I'm given V1, I'm given P1, I'm given V2. So the only thing left for me to solve for P2. Okay, so if I look at this formula and I rearrange this, then P2 is approximately equal to P1 times V1 divided by V2. Okay, and this just becomes a simple plugging in. So what is P1? That happens to be 1.02 atm. V1 is 2.75 liters. And then V2 dividing all that is 3.25 liters. Okay. Notice that liters and liters cancel out to give me atm, which is what I wanted. So if I plug this in my calculator, I should get around 0.863 atm. Okay, so that's a classic problem of these types of Boyle's law problems. So let's take a look at the next one. Okay, the next one is Charles law. Okay, and what Charles law says is that as the temperature increases, the volume also increases, provided that the pressure and the number of moles are constant. So in Excel, if you're doing your graph, again, temperature is on the x-axis, volume is going to be on the y-axis, but what you should get is a linear function because they're directly related. So as the temperature increases, the volume also increases. Okay, so that's the general idea behind this one. Now, the formula that we should remember is the idea that of V1 divided by T1, that is approximately equal to V2 divided by T2. Okay, and again, we're going to talk about how we actually do not have to memorize what that formula is. And so the example problem says, okay, well, what if I'm given V1, I'm given T2, I'm given an unknown temperature, so that might be T1. Okay, and I'm given V2. Well, what is the unknown temperature, which is essentially T1? Okay, so if I rearrange this equation to solve for T1 using algebra, then we're going to get T1 to be approximately V1 times T2 divided by V2. Okay, and for those of you guys who did not see how I got that, all I did was just rearrange the equation using algebra to get this T1 here. Okay, and then as you can see, this now becomes a matter of plugging in. So what is my V1? That is 2.8 liters. I'm going to multiply this by T2, which is 0.00 degrees Celsius. Now, there's something that I want to mention here that we should know, okay? We always need to convert our temperatures to Kelvin. Okay, so whenever it's given degrees Celsius or these types of problems, we need to convert it to kelvins. And so we know 0 degrees Celsius is actually 273.15 kelvins. Okay, and we're going to simply divide that by V2, which is 2.57 liters. Okay, and when I plug this in, my T1 should be approximately 297.6 kelvins. Okay, if we leave it in kelvins, because liters and liters will cancel out. Okay, or if I want to convert it to degrees, this is actually 24 degrees Celsius. So this is how we would solve for a new temperature. Okay, and then the last law is Avogadro's law. Okay, and this says as the number of moles of gas increases, the volume also increases, provided that both the temperature and the volume are and pressure are constant. So again, you should see a linear function with the volume being on the y-axis, number of moles being on the x-axis. Now for this one, we need to remember this idea of the PV is equal to nRT. And so with that being said, we could then solve for either the volume or the number of moles. Okay, but really and truly, this is the only formula that we need to remember. Okay, so I have this problem here. It says calculate the volume occupied by 0.84 moles of nitrogen at 1.37 atm and 315 kelvins. Okay, well, if we know that PV is equal to nRT, oh, and I forgot my R. This is a constant, so this most likely will be given to you. But you'll use it so much that it'll become something that you just automatically memorize, okay? And so that being said, calculate the volume. Well, I'm solving for V, okay? And so in this case, we know V. If I divide by P on both sides, then V is going to be equal to nRT divided by P. And so this becomes just a matter of plugging in. So if I plug in my numbers, well, the moles is 0.845 moles. Okay, I'm going to multiply that by R, which is a constant. So this is 0.08206 liters per atmosphere, mole per Kelvin. Okay, the pressure is 1.37 atm. Okay, and the last thing I need to plug in is my kelvins, so 315 kelvins. Okay, now we're solving for volume, and so when I plug this all into my calculator, I should get about 15.9 liters. Okay, now take a look at how the units cancel out. I have moles on the top, moles on the bottom, so those will cancel out. I have Kelvin on the top being multiplied, Kelvin being divided, so those will cancel out. Okay, I have atmospheres on the bottom and atmospheres on the top. The only thing I'm left with is liters. Okay, so these are the three fundamental gas laws that we should remember. And then we're going to talk about, next video, we're going to talk about how to actually forget memorizing these formulas and how to derive them.